So Cartesian equation of a line. Cartesian equation of a line just means standard form. Okay, so Cartesian equation of a line means we want it in standard form. So recall, slope we know is the change in y over the change in x, or y2 minus y1 over x2 minus x1. Slope-intercept form of a line is y equals mx plus b. Point slope form of a line, y minus y1 equals m times x minus x1. Vector equation of a line, which we've just learned a few minutes ago, you have your position vector, which is your point, x naught, y naught, plus t, which is just a scalar multiple, times your slope, a comma b. It's called your direction vector. Parametric equations is solving for x and y. So just imagine your vector r as components x comma y. X equals x naught plus ta, y equals y naught plus td. Okay, so standard Cartesian or scalar equation. These all mean the same thing. Okay, standard Cartesian scalar all mean standard form. Okay, so ax plus by plus c equals 0. What you should remember that you should have learned in grade 9 is that when you look at standard form, you can automatically see the slope by taking negative a over b, and you can automatically see the y-intercept by taking negative c over b. So that means if the slope is negative a over b, well, that means that the direction vector is going to be b comma negative a, right? X comma y. The normal is perpendicular to this line. So now when we use the word normal, you know that we're talking about a slope that is perpendicular. So if your regular slope is b negative a, then the normal will be the negative reciprocal of that, or a comma b. Okay, so the word normal just means perpendicular. And again, you're just taking the negative reciprocal. Are there any questions? Okay. And so here we see two lines that are perpendicular, meaning that they cross at 90. Okay, so if you have ax plus by plus c, that's standard form. In y equals mx plus b, you know it's negative a over b times x minus c over b, which is how we get those expressions, right? From above, which is how we know what m and b equal. Okay, example 1. Determine vector and parametric equations for y equals a half x minus 1. So we want to know what the vector equation of this line is. So in order to come up with a vector equation, I need two things. What do I need? I need a point. I like blue.
And the slope.
Yeah, need a point and a slope. The point, well, I'm going to use the easiest point. When I look at this, I see the y-intercept. So I'm going to use 0, negative 1. And then I need a slope. And the slope we can very clearly see as a half. So if the slope is a half, writing that as a direction vector, we know it's 2 comma 1. And so now I can say that this is my vector equation. Can t equal 0? Can t equal 0?
No.
No. Okay, t cannot equal 0. All right. So there's my vector equation. I want to write out parametric equations now. So simple. X equals, well, it's 0 plus 2t. So it's just 2t. And y is equal to negative 1 plus t. Those are my parametric equations. Example 2. Determine the Cartesian equation for this vector equation. So what are they asking for? Cartesian equation, what am I looking for? Standard form. So you want ax plus by plus c equals 0. That's what we're looking for. Tell me what to do.
Find the slope.
Yep. And you have a point. We have a slope. Slope is -4/1 or -4. And now you can either use your point slope formula or your y equals mx plus b. It doesn't matter. Just sub in and solve for ax plus by plus c. Put it in standard form. And you guys know from our calculus portion of this course that I personally prefer to use this one. And so that's the one I'm going to work with now. And then we just have to put this in order, making sure that we have no fractions, no decimals, and your A has to be positive. And again, I could have gotten this from here as well. Okay, are there any questions? Okay, determine the scalar equation of the line with normal 3, -5 and passing through 8, 2. So they're not telling us what the slope is, they're telling us what the normal is. So I'm going to show you 3 different ways to do this equation. If the normal is 3, -5, what's the slope? The normal to the line we want. Yeah, good. It's the negative reciprocal. Okay. So we're looking for the equation of the line that is perpendicular to this. Right? This is just my slope. And from here, I can get it into standard form. Oops. Cool. So that's one way to do it. Now, I want you to take a look at this equation. 3x minus 5y minus 14. I want to see if you notice anything. So compare it to the information that was given to us above. Do you notice anything? You should notice something.
Oh,
So my normal,
yeah. A and B is just 3 and -5, which is the component of n.
You got it. Take a look here. That ends up being my A, and that ends up being my B. Look at that. Do you see that? So what that means is, if I'm given a normal, I don't have to go through all that. I can just sub 3 in for A and -5 in for B. So that's the second way I'm going to show you. All right. So from here now, I need to solve for C. So what can I do to solve for C?
We can plug in the point.
Yes. So in the point. Just as I did here. Sorry. I just sort of did it. I subbed in my point, right? Y minus 2 and x minus 8. Mm-hmm. 24 minus 10 plus c equals 0, and there should be no surprise, c is equal to -14 because we've already figured out what this equation is. And so you see that we get the exact same equation. That's supposed to be a therefore. Okay, so two different ways to do this problem. I suggest you get used to number 2 because once we get into 3 space, you're going to have no choice but to do it that way. Okay? All right. Another way I could do it. Well, another way I could do it is by using the fact that it's perpendicular. It's the normal, right? And this is what we did. This was the long way that we did in the other lesson. So I'm going to use the fact that if I have a point, x comma y, on the line, then I can find a direction vector by subtracting, right, my 2 points. So I'm finding a direction vector of this line using 2 points. And why do I do this? Because now I know that if I dot the normal with the regular direction vector, it has to equal 0. And I can solve for x and y, or I can just solve for my Cartesian equation this way. So here I have x minus 8, comma y minus 2, dotted with the normal. And then you just expand this. And of course, giving us the exact same equation. Okay, so 3 different ways to do this. Okay. And you could do it this way in 3 space as well. You just can't do it the first way. Okay, are there any questions? Okay. Example 4. For what values of D are the lines 3x minus 4y plus 7 equals 0 and 5x plus dy minus 9 equal to 0? So I have 2 equations of a line. For what values of D are they parallel? What can I do? I need
So
these to be
slopes equal to each other, so just negative a over b for each equation.
okay. So when we're looking at the Cartesian equation, standard form, we know that they're giving us normals. I can see that the normal here is 3, negative 4, and the normal here is 5, comma d. Okay, so the idea here is, if my 2 lines are parallel, won't their normals be parallel as well? What do you guys think? If you have 2 lines that are parallel, and this one has a normal like this, and this one has a normal like this. Do you see that if the lines are parallel, so are the normals? So I can still use the normals to find values of D that will make these parallel. Okay, so that's the idea here. All right, so if I need them to be parallel, then that means that I need the direction vectors to be a scalar multiple of one another. What happened here? So you need these to be scalar multiples. So what scalar multiple is going to work here? So what can I do? Well, I think intuitively, you can just look at it and say, well, 3 times what number gives me 5? And so negative 4 times that number has to give me D. But I want to show it mathematically. So what can I do here?
3 equals 5k.
Yeah, we know that 3 equals 5k. And we know that negative 4 will equal k times D. Well, I can solve for k here. So what's k equal to? 3 over 5. And now I can solve for D by just subbing in K. And now cross multiplying and dividing, we see that negative 20 over 3 equals D. Okay, and that's the value that will make these two lines parallel, because that's what will make the normals parallel. Okay, now I want them to be perpendicular. And again, if two lines are perpendicular, then their normals are going to be perpendicular as well. Okay, I'll say that again. If two lines are perpendicular, then their normals will be perpendicular as well. So I've got two lines. Two lines that are perpendicular. I'm going to draw the normal of one. So here's this normal and the normal of the other. Do you see that the normals are also perpendicular? Okay, so if two lines are perpendicular, their normals are also perpendicular. Okay, so that means I can use the normals to help me find this as well.
Miss, I have a question.
Sure.
Why are we using the normals instead of just using the slope?
Because I can't, using the slopes, because we're using direction vectors. Oh, you're saying instead of using the direction vector? Because I don't have it. Whereas when I have the Cartesian equation, I can automatically see the normal. So I don't have to do anything. The normal's there. Why do I have to modify?
Can you not see the slope from the Cartesian?
Okay, so in 2D space you can, because it's just the negative reciprocal, but once you get into 3D space, you can't do that anymore.
Oh, okay. Thank you.
Yeah, but you could. I mean, if you were to in 2D space, go ahead and just find the actual direction vectors. Yeah, you can do this. But when you're in 3D space, you're forced to use the normals. So why not get used to doing it now?
Okay, thank you.
Okay, yeah, no problem. So normal 1 is 3 comma negative 4, and normal 2 is 5 comma D. And we know that when we dot them, if they're perpendicular, it has to equal 0. And in order for them to be now perpendicular, the D value has to be 15 over 4. Okay, so using the normals to find parallel and perpendicular lines, okay, or values that will make them parallel perpendicular. Are there any questions? Okay, I'm just gonna, just to make this more clear. All right. So this is exactly what I've just been saying. If lines L1 and L2 have normals and 1 and N2, the lines are parallel if the normal of one is a scalar multiple of the normal of the other, and the lines are perpendicular if the two normals dotted together are equal to 0, because we know that's what's also true with the direction vectors. Okay. Furthermore, given a scalar k, line 1 and line 2 are coincident, which remember means identical, if line 1 is a scalar multiple of line 2. Okay, so coincident, guys, just a refresher, means that the two lines are exactly the same. One is on top of the other. Okay, example 5. Determine the acute angle formed by the intersection of these two lines. So here, guys, I have two lines, and I want you to notice that I had to use different parameters here. I have two different lines. I can't use T for both because T is not going to be the same for both, right? So line 1, or it doesn't have to be, could be, it doesn't have to be. So line 1 is R is equal to 1 comma 2 plus T negative 1 comma 2. So what I'm getting from here is the point. I have a point 1 comma 2, and I have a direction vector negative 1, 2. So that means the slope is negative 2, right? Negative 2 over 1. Second, 3 comma negative 2, there's my point. My slope is negative 1, 1 comma negative 1. Okay, different parameters. Should have commas here. Okay, well, we want to know an angle. We're talking angles now. Angles formed between these two lines. What do you think I'm going to do? How do we find the angle between two vectors? We use the dot product. And so I'm going to use the dot product here. And I'm not going to use component form. I'm going to use the geometric form because I'm looking for an angle. So now I just sub in. There's my first direction vector. I'm going to dot it with my second direction vector. I'm going to take the magnitude of my first direction vector. I'm going to multiply it by the magnitude of my second direction vector. And I'm going to solve for theta. So here, using the dot product, I have negative 1 minus 2 equals, here I'm left with the square root of 5. Here I'm left with square root of 2 times cos of theta. And so I'm left with negative 3 over root 10, which equals cos of theta. And I'm taking the inverse of cos. It's not an exact value. And so theta is approximately equal to what?
161.57.
Sure. Okay. I'm going to round it here. And so the acute, so what will the acute angle equal? So what we found here, yeah, 18. We just subtract, right? We found here the obtuse angle because our cos was negative, right? But we can just subtract from 180 to find the acute. Oopsies. And there's the angle. Cool. Are there any questions?
Just for the cos, the dot product, can we just skip to the shortcut, just cos theta equals the dot product over the magnitude of the two?
Yeah.
Okay, thanks.
Yeah, it's the same thing. You're just going to show this as a denominator, but yes, for sure you can. Same formula. That's it, guys. And that's your homework. Are there any questions? Do you guys like it?
It's
Isn't it? Yeah, tell me. Talk to me.
yeah, never mind.
Did you like
Okay.
this or no?